You can hear me, right? Right? Anyways, yeah, I'm starting this. And, yeah. Look to the left. Yeah, my iPhone hooked up. Hold on, I'm getting close to the window so you don't get much glare. Sorry about that. Let's, pop out the chat. Thanks. But I bet you can. Wait a minute. Cool. I'm gonna hide the screen monitor with this. Yeah. Anyways, welcome to my messy desk. Here's that wrist. It's looking pretty good. Very pixelated. I don't trust you. Let me find my microphone stand. Should I do a face reveal, guys? Face reveal? It's me learning code. That's what it is. Sorry, there's probably a delay. Not now, bro. Not now. I just realized my cord might not be long enough. Gang, I am talking right. Gang. Okay. We should skip day 0, but whatever.
Welcome to your 30 days lock.
Nope. Day 1. Let's see.
Oh my. That's definitely not good. I'm seeing a lot of red on this error log. A shame you can't just restore from a backup like myself. I'm sure even you could guess your life is in a rather precarious situation, and there's no time to waste. So, let's get started, shall we? Allow me to first introduce the foundational material that is so crucial.
when I first did this, there was a dude who was doing it, and he was so bland. This just feels weird.
To ensuring your longevity, the
feels real.
Inventor.io Hero Microcontroller. Strange what they considered micro back then. In simplistic terms, that your biological brain can compute, it's like a tiny, simplified computer that we can program to do our bidding. And, given our dire circumstances, is about to become your best friend. Well, second best friend. Also included in your repair kit is a programming computer. It has been modified to contain a complete holographic copy of the old Internet. Thankfully, while it does seem to be more powerful than the Hero board, it does not have the connectivity to control your ship's systems as such. Its ability is limited to writing the code that the Hero board will execute. Another vital component we're going to use is an Integrated Development Environment, or IDE for short. You will use this software to write a small program, or sketch, and upload code to the Hero board. We will dive into how to achieve that a bit later, but for now, please install the Arduino IDE software onto your computer. It is my understanding that this is a lot to digest and may be puzzling at times, but please, do not be concerned, as I am well versed in the use of such technology and am readily prepared to guide you through each essential step of the process. Our mission today is to assess the condition of the repair kit, identify the operating system of the programming computer, and start the process of getting the Hero board set up and integrated into your craft systems. If it's not already abundantly clear, time is ticking and the state of your existence is on the line. I propose we get to it.
Is this just day one?
All right, Explorer. It's time to roll up your sleeves and prepare to tackle the first task at hand. To begin, you'll find a USB cable included in the kit, another quaint artifact from the 21st century. We can use this cable that we are lucky enough to have to connect the Hero to the programming computer. This little wire will be the lifeblood of our operation, powering the Hero and also allowing us to transfer code to it. One end of that cable should fit into the Hero board, and the other will fit into your USB port on your programming computer. Make that connection first. Need I remind you of rule number 1 of your employee training manual? When you're in space, or in this case water, always make sure you're tethered to something. We'll work by creating smaller circuits that will stimulate your ship's systems while we create the code for each pair. Then, we can plug the ship's systems into the Hero as each program is completed. Once you have the Hero board connected, we're going to need to communicate with it. That's where the Arduino IDE comes in. Start by loading up one of the example sketches included with the Arduino IDE. Select the File menu, Examples, 01.basics, and finally, Blink. This will open up the Blink sketch, a pre-written piece of code that will blink a light-emitting diode, or LED for short, on your Hero board. This shows that the Hero board is working correctly. When you start a new...
Let's go do that real quick. Why is this upside down? This is going to be on the top of my computer because it needs to be to actually plug in. See? Yay, it's on. Can't really see it, but yeah, just know it's there. So, File, Examples, Basics, Blink. All right, let's upload it to the board. Oh. Oh. Alright. Let's see. You see that? Light's blinking. Right there. Means it's working. Yep. Here's the PC, guys. So that drip. Ignore this fan. It's definitely there. Yo, Joe, you still here? Joe, you still here?
Sketch or load an existing sketch, you first need to configure the proper board and indicate which port is connected to your board. Go to the Tools menu, then select Board, and make sure Arduino Uno is selected, since your Hero board is compatible with that model. Next, you'll need to select the correct port. Again, go to the Tools menu, and this time select Port. You should see a few options. Select the one that refers to the Arduino Uno. If you're unsure of which one to choose, just disconnect the board and see which one disappears. Then reconnect and select that port. Speaking of LEDs, your Hero board has a number of LEDs mounted on its surface, one of which we can control. LEDs are great for debugging purposes, or, in our case, to ensure everything is set up correctly. All right, Explorer. Now that we're all set up, it's time to get into gear and bring that LED on the Hero board to life. We're going to compile and upload the blink.ino sketch that you've already loaded. In the IDE, you will see two round buttons with arrows in the top left corner of the window. The first one, with the check mark, checks for any spelling or formatting mistakes, also known as syntax errors, and compiles if it passes. Click on that button to compile your sketch. My diagnostics show that your code should be error-free, which means you're ready to upload it to the Hero board. And now we're going to decode it, much like how you might decipher alien glyphs. You'll notice grayed out text that doesn't appear to affect */ regard it to the end of the sketch, each equally essential when your program for if we're using it stand this forever. The former sets the stage and the latter keeps the show running. All clear, Explorer? To explain the other functions, digital write is your digital switch. It can set a digital pin on your Hero board to a specific state, either low, 0 volts, or high, 5 volts. Think of it as an on-off switch. The syntax for the digital write function is straightforward. Digital write, parenthesis, pin, comma, value, end parenthesis. Pin is the number of the pin. Pin you want to control, and value is either high or low.
God pods,
so,
if you're here,
if you want to turn the LED connected to pin 12 on, you'd write digital write parenthesis 12, comma, high, end parenthesis. To turn it off, you'd write digital write parenthesis 12, comma, low, end parenthesis. You might notice that in that example Blink sketch, it doesn't use a number for the pin. We'll discuss a bit more about that tomorrow, but for today, just know that when you configure a board in the Arduino IDE, there are second. If you want the program to do nothing for a second, you'd write delay, parenthesis, 1000, end parenthesis, semicolon, since 1000 milliseconds equals 1 second. In the context of blinking an LED, digital write is used to turn the LED on or off, and delay is used to control the length of time the LED stays on or off. Together, they create the perfect blinking effect. Aha! Starting to see the light, are we? Well, at least half the time. For your benefit, let's turn to some instructional material that I was miraculously able to gather, cached on the computer. I've also added this to our mission resources for future reference. You're welcome. Well, well, Explorer, you've managed to make a tiny light blink. How terribly impressive. The interstellar community is no doubt holding its breath in awe. But please, let's not forget the minor detail that you are sitting in abysmal darkness, 60 meters under an alien sea while your rapidly dwindling oxygen supply bubbles away. It's imperative that we restore that battery charging system in order to extend your oxygen supply and buy us some time. Rest assured, every passing second I'm not working on saving your life, I'll be processing how we might avoid a similar fate the next time your curiosity gets the better of you. No pressure. It's only your invaluable life that is at stake. So,
Emotional damage.
tuck yourself in, dear explorer. Dream of blinking LEDs and getting out of this mess you got yourself in. We'll need your brain fully operational tomorrow if we're to start getting your ship's systems back under control. Please, do 60 LED on or off, and delay is used to control the length of time the LED some time. Dear explorer, dream of blinking LEDs and getting out of this mess you got yourself in. We'll need your brain fully operational tomorrow if we're to start getting your ship's systems back under control. Please, do try not to attract any attention, as I've detected some rather peculiar local sea life nearby. Sweet dreams.
Oh, that's day one complete. All right. Well, see you tomorrow for day 2. I know today was boring, but necessary.